Greetings, Marsh here, and welcome to episode 111 of my modded Factorio playthrough. In this episode, we are going to use helmod to plan our new smelting setup. Enjoy! And on its core, smelting is fairly straightforward. It's just we take those ingots and melt them in various alloys into a liquid, and then that liquid metal gets pressed into plates or whatever. But unfortunately, this setup right here is a little simple. And what we're going to do isn't hard, it's just, let's call it organic. Because there's lots of different ways we're going to have to handle everything. We can use helmod to try to figure some stuff out, but we won't really be able to use helmod to plan the entire setup because it's just going to be too spaghetti for that. But we can use it to get an idea for how big stuff's going to be. So we want to plan on our various outputs, and we'll have to go through them all. But it'll be aluminum plates, copper coils, copper wires, glass, iron sheet coils, lead sheet coils, nickel sheet coils, then monosilicon, silver plates. We're going to do refined concrete, which is going to be an afterthought, but we'll have to put it in there somewhere. Tin sheet coils, tinned wire coils, zinc plates, steel plates, solder coils, bronze plates, brass plates, gunmetal plates, and invar plates. So we have to create all of those things. There's basically like two halves of this. It's the first step is turning it into the molten version of what you need. And then the second step, which is much more straightforward, is just creating the item. To give you an idea, let's just try to do an example plan here where, let's say we want to make molten iron. We have three different ways of doing that. With ingots, iron ingots directly, or by mixing half manganese with it, or half silicon with it. Well, what kind of limits do we want? Well, our production limit is going to be based on if we're using all of our iron ingots, because it'll take less iron ingots to make iron from these other methods. So the first method is the least efficient with iron. So let's switch this to input. And we know we're going to have 120 ingots a second, just because that's how we planned our base up until this point. You see it 26.7 induction furnaces to create our 1200 molten iron. And then we can take that molten iron and turn it into sheet coils, which will require 60 strand casting machines and lots of water. And these casting machines are fairly large, so it's going to take up a lot of space, which is going to be a problem because we're running into water, and certainly we're going to need to expand this wall. We do have a lot of landfill, so we'll have to see how big all this stuff gets, but I'm hoping we have enough landfill just to keep going up and have this whole thing be straight, because I like straight. I don't want to have to turn it to the left here. Plus, as long as we're going on water, we're not covering any resources, which is convenient. And I know we have like about 100,000 landfill, and it disappears real fast, but we can make more if we need to. And we'll also want to put these on the bus, just because we're going to be making so many of them. But this is only one method of making iron. We're actually going to make it using two other methods. And also, I should probably note that those sheet coils, even though we're making 120 iron ingots, gets crunched all the way down to 30 per second, so a single red belt, which will really help with transportation. But we have two other ways of making molten iron here, and because of the way helmod works and wants everything to be balanced, it's not really going to work very well by adding that stuff in here, so we're gonna make a separate line right here where we'll do the second method, which is iron and manganese, which makes our iron, which goes into the coils. Now we know that our limiting factor here is 30 coils a second. So although we can make even more coils per second with this method, there's kind of no point because the factory won't be set up for it. So let's set this for 30. So now we're kind of going backwards a little bit, but you can still follow here, where we will need only 60 iron ingots and 60 manganese. And first we have to check, are we going to have 60 manganese? We can come up here, and we will not. At maximum, we will only have 30 manganese a second. So we need to come in here and fix this. Set this to 15. Because the rare item here is the manganese, and that's the limiting factor for this setup. So if manganese is available, this is the most we can do with it. So we would need 6.7 induction furnaces handling the manganese and iron, and then we would need the 26.7 for iron, because we don't know which one of these lines is going to run. So we need to set them all up to run at full power, depending on what the factory needs at the time. But this one isn't set to full power because this is the maximum of manganese that we have. But let's say we did set this to 30. You can see how strands casting machines is 60, and it's also 60 here. So we only need the one smelting machine for the output that we want. So the iron coils. The thing that changes that we need to have multiples of is the induction furnaces. So even though this one says we only need 30, this is kind of a blank entry that this doesn't matter. The thing we cared about is the 6.7 here, induction furnaces, added to the 26.7 for just straight iron ingots. And now we need to do it again with silicon. And how much silicon are we going to have available? At maximum 30. So we can set this to 15 again, which means we also need the 6.7 induction furnaces. So here we have our setup where there's going to be 26.7 furnaces for just straight iron ingots, 6.7 for mixing them with manganese, and also 6.7 for mixing them with silicon. It's also worth noting that when you're making alloys, the furnaces are much faster than if they're using straight ingots, so you need much less of them. So we need to add those three together and combine their pipes, and then all three of them will have an output of these 60 strand casting machines going into sheet coils. And we'll need to have some logic set up, and it might be worth just building each one of these setups individually, because they're all going to be different based on just what kind of alloys we're dealing with. Like some of them, there's only one way of making them. Like making lead coils is only made from lead, but some of them are kind of complicated, like with solder here. So I think we should probably just design each one individually and then Lego them all together once we're ready. We're going to need to manufacture some of these machines. We need induction furnaces, casting machines for making plates, and the strand casting machine for making coils. And let's see, do we need the sintering oven for anything? Not right now. So probably don't need to build them. But we do need to handle these other kinds. And I don't think we are manufacturing those yet. So let's make a new line. And here we go. It looks like they all use a very similar set of resources. Probably this same set here. But this line is getting awfully long. So let's double it back. Like right here. Right there. Then there would be 5 spaces in between. Yellow, red, yellow. Something like that. Not sure where the turnaround should happen, but let's do it. Like right there. Just all these resources are exactly what we need. So, why bother pulling it off the bus again when this one set has been working just fine? Probably should have turned this around sooner, but that's alright. Okay. It looks like they're all pretty much exactly the same. They require some kind of brick. steel, some kind of gear, some kind of circuit, and some kind of pipe. And the previous tier, if it was available. So it looks like there's not too much difference between them. Okay, well, this one can make the tier 1. That one's tier 2. Okay, that should work. Let's see. Looks like I got these reversed, so let's put this one up there, this one down here. Looking good. Let's do the same thing again. But switch this to casting machines. Let's see, how many should we set this for? Probably like 50 of them. Let's do the same for this. We'll actually probably need a bunch more. Let's do like 100. Okay, there we go. Looking good. Finally, strands casting machines, which we did need quite a few of them. Let's just set it to 100. That should be the other machines. Looking good. It's going to take actually quite some time to make 60 of those. Well, while we're waiting for that, we can continue doing some planning here so we can get rid of that. So we planned iron here. One important thing to minimize the amount of spaghetti is that we positioned these in such a way so that the belts would have to travel the least amount of time to get to each one of these induction furnaces. And we're going to potentially have a lot more belts going around, and it's going to be nuts. So we still want to do this where we try to position things in a way that makes sense. For example, making these bronze plates with copper and tin between where we're making copper plates and tin plates, just so there's less overlap of belts. So one thing that is made from iron is steel. And steel is actually going to be next door anyway because we're already making the steel plates. So we probably want to plan that. But I don't think iron actually goes into anything else. Let's check. Iron ingot. You can see the ingredients is molten iron only. And manganese cathodes, actually. But for now, let's just worry about the molten iron. So we don't have to worry about that. However, we do have to do steel. And steel's going to be next door. And then we could make Invar as well. Let's see what the steel goes into. Invar, cobalt steel, and various molten steels. Let's just do that steel for now. So we don't have any special versions of the recipes, just regular steel. The ingredient is going to be 30 per second, I believe. Yep. That is if we use all of our iron to make it. And then we make the steel plates and the casting machines. So 6.7 into 20. Not much to say there, and you can see we're running out of steel already. This is definitely going to suck up quite a bit. It might be easier to send the steel to make the alloys as opposed to the alloy components going over to where steel is. I think. We'll have to see how that works. But for now, let's do the next thing, which is copper. We want copper sheet coils made from molten copper. And we only have the one type. So 120. And that's it. There's nothing special there. Although, there is kind of a special element where we're also making copper wire coils as well. So we hit that. Make those from copper. And the input is 120. Now, I don't think we're going to need that much copper wire, so we probably don't need to make it the same size. Especially considering the other wire coils can be made from molten copper, not from copper wire. So we really don't need to be producing a whole bunch of it. Plus 2 whole belts of wire coils seems kind of excessive, so let's reduce this input to 60. So we're making 1 red belt worth of the copper coil. We're just going to have the 1 set of induction furnaces going into 60 strands casting machines for the coil of sheet, and then 30 going into the wire coils. Oh, didn't put any lights in here. There we go. And everything is just very anemic. Okay. So let's check copper ingots. Besides making our molten copper, they also go into making bronze, which is copper and tin, or copper, tin, and nickel, and then brass, which is copper and zinc. I'm not sure if it matters which one we do, in what order, but let's do bronze 1, bronze 2, and then brass. And then gunmetal, which is copper, tin, and zinc. So a lot to be made from copper here. Okay, if we wanted to make bronze 1 with copper and tin, and then making the bronze plates, what kind of output could we have? Well, quite a bit, considering that tin and copper are both mainline products that we can make a whole bunch of. So we're probably not limited in ingots, just in how much of this stuff do we actually want. And 1 red belt, I would hope, would be enough. Are we really going to have a bus with more than 1 lane of bronze plates? I mean, one way to look at this is that this is 20 casting machines worth of bronze output compared to our 6 right here. But let's see what bronze goes into so we can get an idea of how much we might want. Okay, it actually doesn't go into that much stuff. Just all of the various fast things, and bronze pipes, which go into a bunch of machines, but I don't think it's not like it's for science. So I don't think we need a whole bunch of it. So 1 red belt ought to be plenty. So now we have an output of 30 per second. So let's make those bronze plates the other method by adding nickel to it. And this is something we'll definitely want to have some logic attached to it, but our output is those plates. And we want 30 per second. So the same 20 casting machines, but now we only need 2.3 induction furnaces. So this one will be 22.5 copper and 7.5 tin ingots. This one is less copper, more tin, and nickel. So as an example, how would the logic be set up here? Well, my plan is to have the inserters connected to the circuit network for all ingot types. However, the control of the inserters are going to be based on different things. Where the control of the main item in an alloy, so in this case, it's tin and copper, because both of those are required, will run if our bronze plates get low. And then the circuit network for the rare resources, like nickel, that inserter is going to turn on when our nickel warehouse gets too high. It's kind of difficult to just explain this without showing it. The idea here is that we have all these different resources, and you can see that we're overloaded on copper now and overloaded on tin. So we're going to be in situations where we're overloaded on resources. So we're going to want to have logic set up to dump those resources. Now, the reason why you don't want to just do, say, the tier 2 of bronze here is you're going to be constantly using nickel. And you might be stressing your factory to make that nickel when the only way it could potentially be made is with messy sorting like this. So if we wanted nickel, we'd be producing too much lead, and then we'd overload on lead. So the reason we want the circuit network here is this second method will turn on if we have excess nickel. Basically, we want to get rid of it. But if we don't have excess nickel, this will turn off and only have the main system running, because copper we can produce infinitely, and tin we can produce infinitely with no byproducts. So those are much better to make things from. That's kind of why I was saying that each setup for each plate type is going to be completely unique and different from each other, because they're all going to have their own unique logic, pipes and belt setups and all of that. And we're still working through the steel. Might have to go shooting some biters. So that takes care of the bronze. We also needed brass and gunmetal. So we have brass down here. We'll do brass plates from molten brass. And that's just a single recipe here. Can we do 30 per second? Yes, we could actually do 60, because we're making 15 per second of zinc ingots. So the question is, do we want 60? Brass plates do go into things. But the big thing to note is that it goes into these kinetic test plates, and these are for military science, or black science. And this one here goes into the pink science. So I wonder how much a single science pack would actually take of brass, to give us an idea of how much of it we might actually want to make. So let's do the disabled recipes. Grab that. Make 1 per second. And just go through here. Find out exactly how much brass we would need. Not worried about all the separate stuff. I'm just trying to quickly go through it just so we get our numbers. So it would take 4.5 brass per second to make 1 science pack per second of military science. That's actually kind of a lot. And I wonder how much science we're making right now. It's a rough estimate. Well, we have 12 times 2, so we have 24 machines making green science. So how much would that be? $24. So we're making 3 green science per second right now. So if we had 30 brass plates a second, we'd be able to make about 6 or so. Well, let's see. What else does zinc go into? Does it have any other use, or would we want to use it all up? Well, it goes into that brass. Gunmetal, which has some uses, but not a bunch. And a recipe of solder to dump it. So it has some other uses, but it actually looks like its primary use here is making brass. So we probably want to make as much of it as we can. Just so, like, how regretful would I be if I only made 30 per second and then we found out that 6 science packs per second wasn't enough? And then we're like, oh no, wish we had more. We have all this zinc just sitting around, but we can't use it. Shucks. Well, let's just try to plan to use all of it. So let's set this based on input and set the zinc ingots to 15. And there's our setup for that. And we needed gunmetal. Just down here. Made from molten gunmetal. And this we probably can just set to 30. Because I just don't think it goes into very much. It goes into the armor and then bullet casings, which is important for making high-end bullets. But that's basically it. So just 1 belt is perfectly fine. It's kind of a throwaway thing right there. Doesn't have many uses, but we still need to make it. Okay. How are we doing for machines? Nowhere close. There's no point in trying to build a setup if we don't have enough machines to actually see what it's going to look like. And I don't like staring at ghosts all the time, so... So we wait. This might be a sign of things to come. If I do recall, a couple of episodes ago, it took about like 2 or 3 hours to make the 480 crystallizers we needed for the crystallizer setup, so... And that was waiting on steel, too. So I was thinking, oh, I should probably go out and kill some biters, but actually, maybe we should plan all of this first. And then see if we can build all of them. And then if we still have time, or, you know, we still need to wait on steel, which will probably be the case, then that's when we can go outside. Because there's certainly a lot of biters that need removed. And some walls built. Building walls is easy, it just takes time. There's really no easy way to do it. You just gotta grab resources, go out there, and let the bots get to work. So I don't terribly mind doing it in this way. So that's all the things that copper goes into. So now we need to pick something that goes into what we just created. So we have tin and nickel, or zinc, or more tin. So tin, nickel, or zinc. Well, with zinc, it actually goes into very little, like actual zinc plates. Like, we'll certainly need it eventually, but we don't really need it right now. Silver zinc battery. That's battery 3. That's a ways away. So actually, we probably can just skip making zinc plates at all. Just because it doesn't really go into that much. At least not right now. It will eventually. So that leaves tin and nickel. Certainly tin is a big one. But what about nickel? Goes into Invar. And steel is nearby, so it would be nice not to have to make steel travel too far to get to this. That's basically that. And as far as nickel plates, it's just piercing around magazines. But do we actually need to make them? Because we have so much ammo right now that I may regret stopping production of ammo, but we have boxes and boxes of it right now, so I don't think we need to worry about nickel plates. And things like these Roboport arrays are also fairly far in the future. So making Invar probably makes the most sense. And then those Invar plates do go into lots of tier 2 stuff. It's basically like the higher tier of steel. And of course, into science packs. So let's do that. Let's do some Invar. It's also on the bottom here. Invar plates for molten Invar, and we only have the one way to make it. We probably want to limit it by either nickel or steel output. Well, actually they match. We're going to be producing 30 steel a second. We're also going to be producing 30 nickel per second. Looks like it takes more steel than nickel, so steel is going to be the limiting factor. So I've noticed a potential problem where we don't really have that many sources to get rid of nickel. Just bronze and Invar. So it means that if our factory is going full blast making nickel, we actually won't be able to get rid of it all at once, which is kind of problematic. I mean, we can turn it into nickel plates, and then those nickel plates would have to be dumped into more ammo, but we've got so much ammo right now that let's just see if it's a problem. And then if it ends up being a problem, we'll deal with it later. So we got the Invar taken care of, and we're not making anything with zinc. So the only thing that's left of the bronze alloys is tin. And tin we do need as far as tin plates. And also tinned copper wire as well, so we probably want to do the tinned copper wire first. But this will require 2 different liquid inputs of molten tin and molten copper. I think we did 30 per second of the copper coil, so let's just do 30 per second of these as well. Because that's going to be 120 per second of the actual coils, the actual wire, so that's going to be a lot of resources. And if this ends up not being enough, we can always make more from the plates. Okay, well, molten tin comes from tin ingots, and molten copper comes from copper ingots. So 6.7, 6.7 into 30. And now we need to make the tin sheet coils themselves from their own set of induction furnaces. Set this based on input, because we're actually going to be making 60 tin per second. So this is limited in scope, just because we want one belt. But because we want one belt here, and they're compressed, means we can actually get away with the full amount, giving us our 15 coils per second. Okay. How we doing? 45. Almost enough. Well, since we're already so far in planning this, probably should just plan all of the resources to stay on topic here. So we have tin. So it goes into bronze, which we're already making, gunmetal, and the tin, but now we can put it into solder. And we have 2 different ways of doing that. We actually have 3 different ways of doing that. It's just only 2 of them have tin in it. Well, that's the solder mixture, which is the bad version, so we effectively have 2. So we'll do solder coil for molten solder, which is tin and zinc or tin and lead. Let's do tin and zinc first. Let's just do 1 red belt and see what it looks like. We will not have that much zinc available. We only have 15 per second, which means we'll have to do it in this way. Then we have a second method of making it with tin and lead. We might potentially want to make more of this, but for now, we'll just do that. 1 red belt. Going to 2 belts of anything on this setup's going to be fairly significant, considering we're going to have so many different individual lines of resources that if any of them double up, then that's it's going to start taking up a lot of space if suddenly we have 2 of something or 3 of something. So here we go. So the way this is going to work is the fallback method is going to be tin and lead, because we're making that with no byproducts. However, if we're running low and we've got an abundance of zinc, we'll do it this second way to get rid of the zinc, basically. We're always going to use tin, but just the question is, do we want to use lead or use zinc? And lead we're unlikely to be overloaded on because we can just produce it on demand. I mean, it's still possible we can be overloaded on tin as opposed to zinc, but I think we should prioritize getting rid of zinc first. Okay, let's do some lead then. Goes into brass, but we don't have that recipe yet. Things are going to get especially complicated with new recipes, but I'm not going to worry about preparing for that. So it looks like we can just make regular molten lead and then make our plates. So lead sheet coil for molten lead. And we're going to be producing a maximum of 60 per second of them, which will make 15 sheet coils. Okay, so how are we doing here? Is that it for the alloys? Because then once we're done with the alloys, it's less important where everything else goes. So we still need to make aluminum, but that's direct. In glass, which is direct. Silicon. Now, silicon is getting mixed way back the way with iron. So we may want to put it near where iron is. It just depends on the position of everything. Like, we're actually making the silicon ingots here, but we're making iron here. So what difference does it make if we make the iron plates here and then send the silicon over, or we have the silicon up here and also over here? Like, it's probably just position things based on what makes sense at the moment for the belts that we have, and not worry too much about what it might look like. We got silver, which is straightforward. And then refined concrete, but that can be just put at the bottom of our concrete setup. And then take some iron down there to make that happen. Yeah, I think that's it for the alloys. Now we're just doing the rest of it here. So we want aluminum plates for molten aluminum. And the input is 30 per second. So 30 plates per second. Then we need glass from glass mixture. And that glass mixture is a silicon. See, we have 30 per second, which we might as well set up to make 22.5 glass. Do we need that much glass? Probably not, but that's just the maximum of silicon, so we might as well line it up. We never know. At least we want to be able to burst it if we need it. Okay, so we need to make monosilicon, which comes from molten silicon and a silicon seed. The seed is also made from molten silicon and nitrogen gas. And that molten silicon is there. Let's do input, because we have 30 per second. Seems like it didn't like that. So let's just set this up manually. So it'll be fairly accurate to just say 30 per second. It's a little bit too much, but that'll get the job done. And we need to make a little bit of nitrogen here, which we could do from gas separation from a little bit of an air filter. So not too much effort there. So that makes the monosilicon, which can be made into the silicon wafers in an assembly machine, and then placed into whatever we need to. And that can be done on site. Mainly because monosilicon is dense where we have one of them, but then once we process it, it turns into 6. So we definitely don't want to put the silicon wafers on the bus. So the monosilicon will be fine. Let's see, what else? We need to make silver plates. And interestingly, you can do it in a furnace if you wanted to, but there's no reason to be inefficient about it. Let's just make the silver plates from the molten silver. And the input is 15. Worry about concrete later. I think that's everything. Certainly seems like it. And that's the end of this episode. On the next one, we are going to build some smelting setups that we planned for. Thanks for watching. I'll see you later.